Hello friends, welcome back to my YouTube channel. Today I will going to talk about multiprocessing, basically in Python. So let's understand the concept of multiprocessing. So the multiprocessing comes from we have either we have multiprocessors or we have multiple cores in a single processor. So currently the processors are having multiple cores inside itself. So they are treat we can treat those cores as a logical processor. So as you can see, so a mode of operation in which two or more processors in a computer simultaneously process two or more different portion of the same program. So basically if we divide the program, actually program is a set of instructions. So if we divide the instructions to multiple processors or logical cores to a single processor, so that is called multiprocessing. So we can divide multiple tasks without waiting for someone else. If we are using a if we don't need to wait for a single instruction to be completed. We can assign multiple instructions to multiple cores, so they will do their works, and then we will combine the result, and then we can easily see the output. So as you can see, multiprocessing system. So we can perform multiprocessing if we have multiple processors. So we have a computer or a motherboard in which we have multiple processors. So we can use multiprocessing. We can divide the tasks over different processors. So those are some, you can say, these are uh, hardware itself. So they are individual processors in a single system. And second one is multi-core processor. As I talked earlier, if we have logical cores in a single processor, so a single computing component with two or more independent actual processing units, so these are called cores. So if I told you, I have a system i5 4th generation. So as you can see, I have two cores. Okay, so this is a dual core processor, and but I have four logical processors. We can call it cores, like this. So currently the processors are coming from dual cores, quad core and hexa core, and either they are coming from 16 core processor as well, and 636 as well. So 13 16 core processor can have 32 cores as well. So like this. So those are logical of course over there. So now let's talk about the type of multiprocessing. So multiprocessing can be of two types. So this will be is a symmetric or asymmetric multiprocessing. So what do you mean symmetric? So symmetric multiplication, we can have uh, these in these multiprocessing system, uh, processor will use single OS, or they will use single RAM as well. So main memory, you can say that. So every processor will use the single OS and the single RAM. They don't have their own main memory. They will share the same memory. So we will have a multiple processor, and we will have a single RAM, you can say that, and we will have a single OS. And asymmetric multiprocessing, and these are going to use in two types, like homogeneous or heterogeneous. So you have to use asymmetric, and if you are going to use only homogeneous, so you will have to use symmetric. So uh, AMP can use both, but SMP can't use heterogeneous processing. So AMP AMP can use single OS as well as uh, like shared OS, like they can use a single OS or multiple OS as well. At the same time, they can use different architecture for their processors. So like if you have and they can use different memory for different processors. So the concept of AMP is like we want to divide, we have a task we have to render a video, and I have another task to work on Excel sheet. So Excel sheet would be like easy to handle, easy process in comparison to rendering. So we can use two cores, like we have a higher cores variant which has higher frequency than the second one. So we can use a higher megahertz speed for video rendering, and we can use a lower gigahertz speed for uh, opening Excel file. So we can use two different cores for uh, different tasks. So we will use the asymmetric multiprocessing over here. So, and we will use a rich GUI operating system on the high performance core, and we will use a lightweighted, or the second terms we are going to use is like real time operating system. So we will use that one for like lower processing so we can get the higher speed than the rich GUI. So RTOS is a real-time operating system. You can say, for example, heart pacemaker or airline traffic control system. They use those operating system to get the result faster. So yeah, so we can use so we have two uh, CPUs like Cortex-M and Cortex-A. So Cortex-M is a lower variant of that ARM architecture, and the Cortex-A is the higher variant. So we will use those architecture. So let's come to the diagram. As you can see, I told you like symmetric multiprocessing use the same single memory, like same shared memory. So this will be the RAM, main memory, and here we have multiple processors, and they are going to use the single bus path. So in the motherboard, they will have the same PCI Express lane over there, and they will use the same path to get the to fetch the memory, as well as the like RAM, and the OS is going to use the same, and they will use the input output with those bus as well. So all of them, all processors are using the same bus and same PCI Express lane. Now come to the asymmetric multiprocessing. So here you can see we have so this is the SMP symmetric. So here we are using single OS, shared OS you can say, and the shared RAM. So this will be homogeneous processing. So here we are using two similar type of processor, because we are going to use the single OS, so we have to use the same processor to run the operating system, to manage the operating system. And here we are using a Cortex-M4, which is a lower version of this Cortex. So here we are using RTOS, so we are using different operating system to run on that processor, and we are using the separate RAM for this process as well. So this is called heterogeneous. So here we are using two different architecture to run multiprocessing. So this is called asymmetric multiprocessing. So this is the concept of asymmetric multiprocessing. So basically we will use higher tasks. We will run high processing tasks over here on Cortex-A, and the lower processing and fast result we can run those tasks over here. Now come to the multiprocessing part. So we have a multiprocessing module in Python to perform multiprocessing, and because we are using GIL global interpreter locks, so we are limited to use that multiprocessing in Python, and basically multi-threading. We will discuss it later, but for now, if we talk about multiprocessing in Python, so this is the class, this is the first class we are going to use. Later we will discuss about multiprocessing as a process class as well. First, let's talk about the pool. So I'm giving some basic idea how we can perform multiprocessing in Python. So pool class offer a convenient means of parallelization, the execution of a function across multiple input values. So distributing the input across processing. So actually what does it does? Actually it automatically handle the multiprocessing. We don't need to do manual tasks over there to run the application. Like we don't need to run the multiprocessing and then we have to close it. To wait for its execution. It automatically do these tasks. So this is the syntax. We have to import multiprocessing and then we can use this class pool, and it accept these parameter 1 2 3 4 5. So it can accept 4 parameters. So all the arguments are optional, so we don't need to pass all the arguments over here. It will accept as none. So if we come about the processes, so process is nothing but processes like how many processes you are going to use. So actually it will if you didn't provide any processes, so it will fetch these logical processes from your system itself. So you don't need to pass over here. But if you have four logical processes and if you provide it 8, then it will not do faster processing because your system is limited to 4. So it doesn't matter. So either you have to provide the default one or you can use the less processes. If you are going to do some more, if you are going to run some other program as well, so you can assign according to your choice. And initializer will be like arguments you are going to pass, like how many, like range or something, how many times you want to run that multiprocessing or something. So you have to provide and make task. So you can assign the work child for worker as well. You can assign different uh, different tasks to the workers as well. So like if you pass here 4, so you will assign 4 workers and every worker do their task. And if we come to the this context, so it is actually a context by which, like when you create a process pool class, so it will use that context by itself. So you don't need to provide this one as well, you can leave it blank. If we come to the points, so let's first move to the program. I will show you how we can. So this is the page over here, the official doc from python.org. Here you can read about this pool class and multiprocessing as well. So you can search multiprocessing over here and you will get the result. Now let's actually I'm going to use the Google Colab, where you can run your program without having a hardware on the system. Like you don't need any, it will run on cloud. You don't need to worry about the processing or something like that. So let me create a new book. So it will create a new book. So this multiprocessing using the symmetric or asymmetric, it basically help you, like it increase through output, and you some there are some disadvantages as well. You have to like the SMPs are like expensive because you have to purchase multiple processors, and like And if we are using the shared memory, so we have to use the large memory to run to handle all the processors, and managing all the processors by a single OS is a critical task as well. So AMP is more convenient than SMP. So our terminal is like ready. I have to connect it. It is connecting. Now it's connected. You can change as well between like if you want to change runtime type, and here you can select GPU or TPU. So basically if you want to train your model for machine learning or data science something, so you can use TPU as well. So I'm going to use CPU because we are not going to use any CPU or something. Okay, I'm terminating other session. Sorry. So let's run it, see if it is working or not. Yeah, so it is working. Okay, so let's if you want to check like how many cores your system has, so if you want to check and you want to put into the pool class by yourself, so you can use import. Sorry, I'm using text tag. So you have to import a OS class, OS module, and you can use os.cpu count, and this will display the cores actually. This collab is providing you the two cores processors to run your application. So actually this is a free one. If you want to use like higher version, so you have to purchase something. So we will do work with this only. We don't need to purchase higher cores. So let's move to the, so first like test on or like simple processing, how we are going to use that one, how we are using, how we will use normal processing. So let's normal processing. So we will use time to like uh, to display the time, how much time it takes to measure time. So now we will create a function. Let's create square. So we will display the square of a function, and we will store it into a square num. Okay, and we will use skewer. Okay, now we have to run our main application, so I'm using main function over here. So let's talk about the time. So start time dot time. Okay, and let's use map function. So this map function will like call this method again and again according to the like the parameter we are providing. So if we use map, and if we pass function and we pass a range, so how many times we want to call this function we have to pass over here. So let's suppose I'm going to call it for five times. Okay, and if we use the, so x will be result, and now our time will be end, so we have to calculate end time. Okay, so good. And now we will calculate our this time. Let's call it t time. So we have to take start time minus end time. So this will be our total time. Now print total time. Okay, so let's run it. I hope it will work. Okay, minus, oh sorry, so actually we are dividing from start. I think it should work. Okay, so it is using exponential form because it will be like 0.6. So if we do 500 over here, okay, okay, so now it should return something. Okay, so as you can see, this is the time. If we passing 5000, so this will, if we lose it, and yeah, so this is the time this program is taking to run this application. And what happen if I sleep it? Sorry, let's first let's create for multiprocessing with the help of pool class. Okay, so here we have to import time as well, and we have to import processing. So we have to import this module over here. Now let's copy this because we are going to use same function but for multiprocessing. So here we will have the same and start time, but here instead of like list map we have to use a pool function. So multiprocessing.Pool, and then we have to pass pool dot. So we have a map function in pool itself, so we will going to use this one. And now so whenever you create a pool object from pool class, so you have to close it as well. So I'm going to use a close function, so it will close the pool function, sorry, pool object. So yeah, so this is the code over here, and yeah, so it should run. So this is returning this time. Okay, so now if we print, sorry, sqr, Okay, so it has been completed. So actually it takes time because we are printing the result. So if we remove it, so as you can see, this is the time, and for this, this is the time for this one. So as you can see, this multiprocessing is taking much time than this one. So actually we are not passing anything, and if we pass something, so it doesn't matter because it is taking default core, maximum core. So why we are getting this time? Because we are running this, and we are calling these functions as well. Actually we are not doing any multiprocessing over here. We are just running this function 5000 time only. So what can you do if you use only 5? Okay, and if you, so I am going to sleep for 1 second every time we run this function. So during this sleep, it will stop for normal function. So this in normal function, it will stop every time we, every time the function call, it will sleep for 1 second. So now let's check the output. So as you can see, it will it was idle when it was in sleep, so it doesn't do any processing. So that's why it takes 5, and these are the actual processing time. So this 5 setting, 5 for 5 seconds, this program was on idle state. So if we come over here and if we sleep over here for 1 second, now let's see the output. Sorry, I'm running it for 5000 times, which will take too much time. Okay, let's move to the 5, and here you can see it only run 3. So what does, it just utilize this 1 second for another, another worker. So actually the first worker go to the sleep, and the another worker is doing the calculation. So like it is switching the task to the another function, another worker, to complete their execution. So that's why it takes only 3 seconds, and the first is waiting for the sleep, and then second is doing working. So they are switching their workers to do multiprocessing here. So that's the concept. So I hope you enjoy the video, and in the next lecture I will talk about the more functions of pool class. We have map, like imap as well, and auto sync, and there are multiple options over there. So we will discuss in brief. So I hope you understand why we use multiprocessing in Python, and how we can minimize the output time over here. So you have to just use the workers. The workers depends on your processing count. If you have the latest processor or high-end processor, you will get more cores or more workers. So actually you can relate workers to the cores, how many cores you have. So that much worker you can utilize over there. So thanks for watching. Goodbye.